Welcome students. Today we will solve third problem on trusses and we will solve this problem with method of joints. So let us start today's lecture. So we are given one truss and we are asked to find forces in all the members of this truss by using method of joints. So we know whenever we are solving any problem on trusses, the very first step is we should identify the supports given in the truss. So in this truss we are given two supports, one is a roller support and second is a pin support. Then we label the reactions provided by those supports. Now pin support provides two reactions, one normal to its surface, one along its surface. And roller support provides only one reaction, that is normal to its surface. So let us label these reactions now. So we have labeled reaction at roller support, which is a reaction normal to its surface. And we have labeled it as reaction at B in y direction. And at the start we know that we assume the direction of these reactions because we don't know their actual direction at the start. So for this reaction we have assumed its direction in upward direction. Now let us label reactions at pin joint. So first reaction provided by this joint will be a normal reaction, that is normal to its surface. And for this reaction we have assumed its direction in upward direction and we have labeled it as reaction at C in y direction because it is acting in y direction. Now let us label the second reaction provided by this particular joint, and we know the second reaction acts along its surface. So we have shown its direction towards left. That is just an assumption because at the start we don't know its direction. And let us label this as reaction at C in X direction. So first step is identify the supports in the truss, then label the reactions provided by those supports. Now what is the next step? Next step is we have to find these three unknown reactions. So how we can find? Through equations of equilibrium. So let us apply equations of equilibrium one by one. So what is our motive? Now we want to find RBY, RCY and RCX. So let us apply the first equation. What is that equation? Summation Fx is equal to 0. So before applying this equation, let us first see how many total number of forces are acting in this truss. So in this truss there are four forces. Three are reactions and one is external force acting at joint A in downward direction and its magnitude is 1.92 kilonewtons. Now for this equation we have to see horizontal forces. And out of these four forces there is only one force acting in horizontal direction. So our equation will be RCX equal to 0. So we got our first unknown. Now we'll apply the second equation, that is summation Fy equal to 0. So how many forces are acting in y direction? There are three forces. It is acting in downward direction, so we'll take this as minus 1.92. These two are acting in upward direction, so we'll consider these two positive. So equation will be minus 1.92 plus RBY plus RCY equal to 0. So in this equation we have two unknowns, we cannot solve it. So let us write it as RBY plus RCY equal to 1.92 kilonewtons, and let us call this equation as equation number 1 for time. Now let's move to the next equation of equilibrium, that is summation M is equal to 0. And we know we consider that point as a moment center at which maximum forces are acting. So at joint C, two forces are acting, so let us consider joint C as a moment center. So if we are considering joint C as a moment center, it means we will get rid of these two forces directly and we will left with only RBY and 1.92 kilonewton. So we have to just observe the moments because of these two forces about joint C. So let us first observe the moment because of 1.92 kilonewton force about joint C. Now it will generate anti-clockwise movement, so movement will be positive. And this is the line of action of this force. And when we will drop a perpendicular from moment center onto that line of action, so we will get this distance, and this perpendicular distance is over here as 7.5 meters. So it means moment because of this will be positive 1.92 into 7.5 meters. Now let us observe the moment because of RBY. Now RBY will generate clockwise moment, so it will be a negative moment. And perpendicular distance between line of action of RBY and moment center is 4.5. It means its moment will be minus RBY into 4.5. So our equation will be positive 1.92 into 7.5 minus RBY into 4.5 equal to 0. So from here we will get value of RBY. Now you can see we got positive value for RBY. So positive sign means that our assumption is correct, so RBY is acting in upward direction. Now once we get value of RBY, now we can find value of RCY. So for that we have to say put value of RBY in equation number 1. So we'll get value of RCY. And you can see over here we got negative value for RCY. So what is the meaning of negative value? That the assumption which we considered for RCY at the start, that is not correct. So actually it is acting in downward direction. So when we will do further calculations, and if we need a value of RCY in those calculations, so for RCY we have to consider its correct direction, that is in downward direction. Okay, so from here we have concluded that RCY is acting in downward direction, RBY is acting in upward direction, and we have found their magnitudes also, and RCX is 0, so it is not acting at joint C. So we will label RBY as 3.2 with its magnitude, and we will show RCY in downward direction and we will label its magnitude, and we will not show RCX because its value is 0. Now what is the next step? Next step is we have to find forces in these three members of the truss, and we know for that we have to apply rule number 1. What is that rule? That we can start with that particular joint at which maximum unknowns are 2. So let us observe these three joints. You can see at joint A, one external load is acting, we know the value of that load, and at joint A only two members are connected, so maximum unknowns at joint are 2. So we can start with joint A. Similarly at joint B, there is one reaction acting, but we know the value of that reaction, and at joint B maximum two members are connected, so it means maximum unknowns are 2. So we can start with joint B. Similar is the situation with joint C. So we have concluded that in order to find the forces in these three members, we can start with any joint of this truss. So let us start with joint C. So we will write step number 1, equilibrium of joint C. So now what we have to do? We have to draw the free body of joint C. So how we draw free body of any particular joint? First of all, we label that joint. So let us draw that joint. Let us label it as C. Then we see how many members are connected to that joint. So over here you can see to joint C there are two members connected. One is horizontal and one is at some angle to the horizontal. So let us show both the members in the free body of joint C. So we have drawn one horizontal line to show this member and inclined line to show this member, that is CA. Now after that we have to consider the direction of the forces acting in these two members, and we know if the members are unknown to us, and we know at the start members are unknown, means their forces are unknown to us. So for such members we consider tensile forces, means we label the direction of those forces away from the joint because we are considering those forces tensile in nature. So this member is named as CB, So we will label the force acting in that member as FCB, and we have labeled its direction away from the joint as tensile force. Similarly, for this member CA, we will consider tensile force that is away from the joint, and we will label that force as FCA. Now after this, next step is we have to see, is there any external load acting at C? No, there is no external load acting at C. Then we have to see, is there any reaction acting at C? Yes, there is one reaction acting at C which is of magnitude 1.28 and it is acting in downward direction. So let us label this reaction in the free body of joint C. So we have shown it acting in downward direction and it is 1.28 in magnitude. Now after that we have to see, is there any inclined force acting in the free body? Yes, there is one inclined force, FCA. So we have to resolve this force into its components. So this is the origin of that force. So from this origin we will draw two components, one along y direction, one along x direction. Now we have to show the direction of these two components. So for that we have to see the direction of force itself. Now force is acting away from the joint. So in these two members also we have to show direction away from the origin. Direction away from the origin. Now after that we have to label their magnitudes also. So for that we have to first find angle of this force with any of these two components. So let us find its angle with the horizontal component. Let us label it as theta. So where is this theta? This theta is over here in the truss. So in order to find this theta, what we can say? We can consider this triangle A, C, D. Let us say this is point D. So we have considered this right angle triangle A, C, D. In this triangle we can say tan theta. This is theta. Tan theta will be equal to perpendicular upon base. That means 4 upon 7.5 is equal to tan theta. Or we can say theta is equal to tan inverse 4 by 7.5. So we'll get the value of theta as 28.07. It means now we can label the magnitudes of these two components. We are considering angle of this force with horizontal component, so this will be cos component, other will be sine component. So we will label this as FCA sine 28.07 and this will be FCA cos 28.07. Now you can see we are ready with the free body of joint C. It means now we can apply those two equations of equilibrium, that is summation fx equal to 0 and summation fy equal to 0. So let us start with the first equation, that is summation fx is equal to 0. How many forces are acting in x direction? There are two forces, FCB and FCA cos 28.07, and both are acting towards left direction, so we have to consider their sign negative. So equation will be minus FCA cos 28.07 minus FCB equal to 0. And in this equation we have two unknowns, so we cannot solve it. So let us call this equation as equation number 1 for time being. Now let us apply the second equation, that is summation Fy equal to 0. So in this free body there are two forces acting in y direction. One is 1.28, it is acting in downward direction, so we'll consider this as negative. Second is FCA sine 28.07, it is acting in upward direction, so we'll consider this as positive. So we will say FCA sine 28.07 minus 1.28 equal to 0. So from here we will get value of FCA. That is the first answer. And we got positive value. So what is the meaning of positive value? That the direction which we considered for FCA at the start is correct direction. We considered tensile nature. So we got positive sign, it means it is a tensile force. That assumption is correct. So next to the answer we have written letter T. T stands for tensile force. So once we get value of FCA, then we can say put this value in equation 1, then we will get value of FCB. So when you will put this value in equation 1, we will get value of FCB equal to minus 2.4 kilonewton. So what is the meaning of negative sign now? For FCB, at the start we considered that it is a tensile force, means its direction is away from the joint. But now we got a negative sign in the answer. So that negative sign tells us that our assumption is not correct. It is not a tensile force. It is a compressive force because it is acting towards the joint. So next to the answer we have shown that it is a compressive force. So we have concluded that in member CA, the force is a tensile force and its magnitude is 2.72. It is acting away from joint C. And in member BC, the force is compressive force. It is acting towards joint C and its magnitude is 2.4. Now, after this, what is the next step? Next step is we have to pick next immediate joint. And for C, there are two next immediate joints, joint B or joint A. So we can start with any of these two joints. So let us start with joint B. So what is the first step? Draw the free body of joint B. So for that what we need? First we need to label that joint first on the paper. Let us mark that joint and label it as B. Then after that we have to see how many members are connected to that joint. There are two members. One is in horizontal direction, second is at some angle to the horizontal. So show both the members in the free body of joint B. So one is a horizontal member, one is at some angle to horizontal. Now we have to show the direction of forces acting in these two members. First of all, we will start with the known member. So which is known member? BC is a known member now because in this member we found the force when we were working on free body of joint C. So BC is a known member. Now in BC we found that force is acting towards joint C. So this force is acting away from joint B and joint B will offer equal and opposite reaction to that action. Means this force is trying to pull joint B towards right, but B will offer equal and opposite reaction to that force. And that reaction provided by joint B will be considered as action in the free body of joint B. So when we will draw the free body of joint B, we have to consider this direction for this known member. So see over here, we have labeled towards the joint, but we will use the same magnitude, that is 2.4. Now let us label the direction in the unknown member, and that member is BA, and we know in unknown member we assume tensile force at the start, so we have labeled the tensile force that is away from the joint and we have labeled it as FBA. Now after that we see, is there any external force acting at joint B? No, there is no external force acting at joint B. Then we will see, is there any reaction acting at joint B? Yes, there is one reaction acting at joint B. It is acting in upward direction and it is of 3.2 in magnitude. So let us show that reaction at joint B. Then after that we see, is there any inclined force acting in the free body? Yes, there is one inclined force acting in the free body. So next step is we should resolve that force into its components. So this is the origin of this particular force. So from this origin we will draw one component in vertical direction and second component in horizontal direction. Now after that we will decide the direction of these two components. For that we have to see the direction of force itself. Now you can see the force is acting away from the joint. So in these two members also, or in these two components also, we have to assume their direction away from the joint. So for this component also, away from the joint. Now after that we have to find their magnitudes also. So for that, first of all we have to decide the angle of this force with any of these two components. So let us consider this angle. So we are considering angle of this force with the horizontal component. Let us say that angle is theta. So where is this theta in the truss? So this theta is over here. So how we can find this theta? If this is point D, then we can consider this right angle triangle ADB. We can say tan theta is equal to perpendicular by base. So perpendicular is 4, base is 3. So we will say 4 by 3 is equal to tan theta. And we can say theta is equal to tan inverse 4 by 3. That is 53.13. So we have found the value of theta as 53.13. Now we are considering angle of this force with this component. So this will be a cos component, this will be a sine component. So we'll label this as FBA sine 53.13 and this will be labeled as FBA cos 53.13. So now you can see we are ready with the free body of joint B. So let us start with the equations of equilibrium now. So let us apply the first equation, that is summation Fx is equal to 0. So how many forces are acting in x direction? FBC, which is of 2.4 kilonewton in magnitude, and FBA cos 53.13. Both are acting towards left, so both will be considered as negative. So equation will be minus FBA cos 53.13 minus 2.4 equal to 0. So from here we will get answer for the last member also. So we have found the force in the last member FBA and we have found the magnitude as 4 kilonewton and we have found that it is a negative force. So what is the meaning of negative answer over here? That means that FBA is not a tensile force. We considered at the start that FBA is a tensile force, but we got negative sign over here. That means that assumption is wrong. So FBA is not a tensile force, it is a compressive force. That means acting towards joint B. So next to the answer we have written letter C, that is for compressive force. So in member BA, the nature of the force is compressive. It is acting towards joint B and its magnitude is 4 kilonewtons. So I hope this particular numerical is clear to you. Thank you very much.